The ice on the North Pole is so near the equilibrium point that any outside subtle influence can easily cause the ice to accumulate or to shrink. And here's my analogy. Suppose I had a box full of bricks and it was sitting on the floor. A slight puff of wind would not move that box. Or if I placed my cigarette on the box would not be pushed down. But if I removed the bricks from this box and pumped the air out of the box so that it became almost the same weight as the weight of the atmosphere here at sea level, it would have in effect become like a balloon that you see at birthday parties that tend to go up because they're lighter than air. But suppose this balloon went up and became deflated and it landed in your yard and it was now dead. It was not buoyant, but it was not heavier than air. And you had such a balloon instead of the box full of bricks, which we've emptied and made lighter. Its weight or mass compared to the mass of the air at sea level is such that any subtle influence could cause it to go up, and any very slight subtle influence would cause it to go down. That's why the ice on the North Pole is notoriously changeable. Not a very good indicator of climate change. Because one year the ice can grow and the next it can shrink and the next year it can grow. You can take your friends on and your yachts, plan on an excursion through the islands above Canada during the summer when the ice is going to be melted for sure, because you know that the ice is shrinking. And you get up there with your friends and your yachts, going to sail through the passage, the famous passage, whatever it's called, that was discovered 100 years ago or 200 years ago by a man looking for a route from the Atlantic to the Pacific. He found it. But a few years later, someone else tried to pass through that same route, and they were trapped in ice and died because the ice flux is notoriously unstable. It is so near equilibrium, temperature being what it is. It's at the point where it can very easily grow or shrink. If, for example, a volcano erupts and there's a little bit of soot in the air above the North Pole that prevents a small amount of light from striking the snow on the North Pole, the cooling effect could be enough so that the ice would grow. Undoubtedly, I have to think about this some more and hopefully clarify what I've just said, but here's a start at understanding how small the CO2 concentration is and how our climate is so near the equilibrium point that it could move up or it could move down. It wouldn't take hardly anything to make the earth warm or to make it cool. But CO2 is not powerful enough to do that. So what is powerful enough to cause the climate to change from a hot period like the Carboniferous to a glacial period such as that which we have just exited a short 15,000 years ago. In geologic time, that is a few seconds ago. And we're now at the tipping point where we could go either way. What could cause a dramatic swing in climate? I suspect it's what scientists call total solar irradiance. Not exactly the same as sunshine, but it's the light that strikes the Earth's surface. It could be caused by changes in the sun's output, or it could be caused by changes in cloud cover, or it could be caused by a magical invisible hand that gets in between the Earth and the sun. You may think I'm nuts, but I believe I have the answer. I have a hypothesis, which is my answer today. And it is based on my nebular theory, which puts forth that our solar system was formed by a huge cloud of nebular gas, the result of an exploding star. The gas condensed. You got to remember that in space, a cold vacuum, things condense that wouldn't condense in the atmosphere of the Earth. I'm talking about condensation, but I'm talking about condensation in the cold vacuum of space. Condensation created the sun and the planets in the solar system and all the rocks and meteors and comets and asteroids. We don't stay in one spot. All of this mass, these planets, move together in unison as the planets orbit the sun through space and encounters the remnants of this cloud of gas, which, contrary to all current scientific explanations, does partially refuel the sun somewhat. As it passes through these clumps, and between these clumps, the sun brightens and dims somewhat. Plus, when we pass out of a clump of interstellar gas, mainly hydrogen, which happens to be the fuel source of some stars, cosmic radiation increases. The stardust, or the interstellar hydrogen, moderates cosmic radiation, which permeates all the galaxies. Inside a cloud of stardust, very thin but very large, we experience less cosmic radiation and therefore an increase in cloud cover. Outside a cloud of stardust, the sun dims. These are two driving factors which could easily affect the temperature of the Earth. Our position in space relative to a clump of stardust, and when I say clump, I mean a cloud that is exceedingly thin, visible through some of our telescopes, and it does block our view. When we look through a clump of stardust at stars far away, it does obscure our view somewhat. So this is why I believe that the Earth's climate swings from hot to cold unpredictably, because we don't know when we pass through or out of a clump, or how big that clump is, or how dense that clump is. But this mechanism that I've just described, moving through space, passing through clouds of interstellar gas, would be a far more powerful mechanism than a slight increase in CO2. Now, if our atmosphere was entirely or largely or composed 50% or 25% or 10% of carbon dioxide, that would surely have an effect. But 400 parts per million is exceedingly small, so that the effect of total solar irradiance is the major driver of Earth climate.